This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 11 of Week 2. Fans and Fan Laws, the bridge from fluid machinery into HVAC. Fan total and static pressure, shaft power, and the affinity laws that scale flow, pressure, and power with speed. 2 reasons fans matter. 1. They sit under HVAC in the Handbook. 2. The scaling rules are the same affinity laws you used for pumps in Topic 6. Sketch a pump curve crossing a system curve. Remember, power scales with the cube of speed, and any fan problem falls. The pivot from fluids into HVAC. 2 pressures, 1 equation. Total pressure is static plus rho v squared over 2. Across the fan total is the rise in total. Fan static is fan total minus the exit velocity pressure, what overcomes duct resistance. Catalogs and most problems quote fan static, but the physics uses fan total. 3 scaling laws at constant geometry and air density. Flow scales with speed, pressure rise with speed squared, power with speed cubed. Identical to the pump affinity laws from Topic 6, one mental model covers both. The cube on power is the rule that bites. Doubling fan speed octuples the motor draw. 3 keyword triggers. 1. Same fan, ductwork, air density, only the speed changes. The constant geometry affinity problem. 2. Fan delivers a flow at a pressure rise. Find shaft power. W shaft equals Q times delta P total over efficiency. 3. Fan curve crosses a system curve at the operating point. Topic 6. Reuse. Tells, RPM, CFM, inches of water gauge, brake horsepower, AMCA, backward curved. Variable table. Inputs on the left, the baseline rated condition, the new speed, standard air density, catalog efficiency. On the right, compute the speed ratio R once, reused 3 places. Flow with R, pressure with R squared, power with R cubed. Bottom row, shaft power from flow times pressure rise over efficiency. The fan curve picture is identical to the pump curve picture from Topic 6. Plot fan pressure rise against flow. The curve slopes down through its useful range. Overlay the system curve, a parabola scaling with flow squared. The operating point is the intersection. To shift it, change the fan speed, or the system with a damper. Same picture, only the fluid changes. Worked problem. A backward curved centrifugal fan delivers 8,000 CFM at 2.0 inches of water gauge, drawing 3.5 brake horsepower at 900 RPM. Ductwork and air density unchanged. Find the shaft horsepower at 1200 RPM. Speed ratio cubed for power. Speed ratio first. 1200 over 900 is 4/3, kept as a fraction so the cubing stays clean. Apply it 3 ways. Flow times R is about 10,667. Pressure times R squared, about 3.56. And shaft power times R cubed, about 8.3. Cross-check with the shaft power formula. Flow times total pressure rise over efficiency. Along an affinity scaled line, efficiency stays roughly constant. So Q times delta P scales as R cubed, the same cube law. If the 2 methods disagree, you've confused fan static with fan total, or the efficiency assumption is off. Final answer, about 8.3 brake horsepower at 1200 RPM. The recap is sobering. A 33% speed increase gives 33% more flow, 78% more pressure, and 137% more power. The motor sized for 3.5 horsepower is now overloaded 2-to-1. Size variable frequency drives for the highest expected speed, not the rated. One more correction. Catalog curves assume standard air. At altitude or with hot supply air, density is lower. Volumetric flow at a given RPM is unchanged, same CFM, but pressure rise and shaft power scale linearly with density. The extended affinity form covers all 3. Flow with N times D cubed, pressure with rho times N squared times D squared, power with rho times N cubed times D to the 5th. 5 traps. 1. Power scales with the cube of speed, not the square. 2. Static versus total fan pressure. Quotes give static. Physics uses total. 3. The density correction. Pressure and power scale with rho. Flow doesn't. 4. If only speed changed, don't also scale with diameter. 5. Fan laws assume incompressible flow. Above about 30 inches of water gauge, it's compressible blower territory. Topic 10. 5 takeaways. 1. The affinity laws. Flow with N, pressure with N squared, power with N cubed. 2. Shaft power is flow times total pressure over efficiency. 3. Fan total is fan static plus exit velocity pressure. 4. At altitude or with hot air, same RPM gives same CFM but lower pressure and power. 5. Fan curve crosses system curve at the operating point. Onward to topic 12. Exam strategy.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.